live, sort of, kind of from this Raspberry Pi Zero. I made a previous video about this, unpacking this, shortly testing this, so as far as I remember, probably a year ago or something like that. And as we are here in T2 release mode, of course, by the way, not leaking some IP addresses or something, hopefully. As you have seen the last days, we've not only compiled T2, but also cross-compiled this T2, of course, being our open source, Linux source, rolling release stuff that has support for cross-compilation. And what I usually do, because with the ARM systems it's even more annoying than EFI, is that at least historically, each and every board required its very dedicated kernel build with just fixed I/O space addresses for all the peripherals and stuff, and even other ARM SOC, all the other stuff. So this would be I/O mem probably, yeah. So all of those, although they work on changing this a little bit, but still you, for most part anyway, need to build your specific kernel. Oh, wait a second, this was even the x86 box. That is eproc I/O mem, obviously. And it's not the first time I test this, of course, when I unpacked this Raspberry Pi Zero. Certainly, by the way, if you're wondering, not only one of the very cheapest ways to get into non-x86 computing, in general, a nice board to use for environmental controls, other I/O stuff, some relays, some whatever. And or if you need to spy on someone, install it in some power outlet, ATM, or wherever, although local laws apply, and don't sue me if you applied this in illegal ways. Anyway, it's not the first time I tested this, of course. I have here some also, this is some official Raspberry Pi something just for the kernel. And did it mount boot? I guess maybe. I guess it did, because as popular as the Raspberry Pi is, I personally didn't get one until this one. Maybe I shouldn't have made the most amazing T2 distribution, but it needs some kind of binary only stuff for starting. Not even sure if everything is open source. Also, initially the GPU situation was not as amazing, although they of course employed someone the last 5 years, so that is better now. But I think it still needs maybe some closed startup stuff. That is, yeah, it's not integrated in T2 because it doesn't make too much sense. Although maybe for the Raspberry Pi it does, to integrate each and every board's binary only startup glue. Anyway, if you want to run this board, you see I don't have anything connected except USB power, and that is only power from an iPhone charger. You can enable in those default images that you find on the internet by other official Raspberry Pi people, also not that, but that. So you only touch on this like FAT formatted boot partition if you install your official Raspberry Pi distribution, and maybe probably leave me in the comments if I should spin a T2 only Raspberry Pi image just for the fun of it. So if you want to log in like this here on the kitchen table, then you just touch a file named SSH in the boot partition, otherwise it doesn't start the SSH server. Again, not in every distribution, but the official, one of those official Raspberry Pi distributions. And then you need obviously your VPA supplicant file there, and that is, actually I could have documented this slightly better, and that also goes to the boot partition and it copies it over. Also some important note, initially I just copied my standard one and that didn't work. And I realized also many other blogs have a more simple file, like some blogs and websites only have this in there. That doesn't work. I've not yet researched why, but I saw on startup it had like country code not set or something, not enabling Wi-Fi. So I think at least this country code is necessary. I didn't check the other two lines, just I used it then from the official Raspberry Pi website, but whatever. So without country code it doesn't work, I think, at least as I tested. And then you can just I think that probably anyway, let's not overcomplicate this. Don't really accidentally wait a second. Yeah, what I've done next, so what I usually do then for testing, because we have cross-compiled this here, on the Ryzen the last night as seen live on YouTube. And if you do this for your own embedded boards, then you can just rsync all the stuff over, which, yeah, I have here a nice host name, not leaking my IPv6 address. So I usually just use rsync-arvtp, for this capital P for partial and progress. And ESSH, I think, by the way, we probably can check this, but I think that is probably necessary, right? Or does it? Oh no, it does this by default now. Oh, interesting. I think in old-fashioned times, a decade ago, it was necessary. But anyway, so then live on this channel, you don't need this anymore. Where you build this, I usually build T2 in user source, T2 trunk, build ARM, something, so this is a more optimized cross build as it has run over last night. And then I excluded toolchain because there is all the cross toolchain stuff in there, and logs, just to save a little bit because the image is already mighty large enough. Let's check this. So actually this is my previous, I said I've not done this the first time, so the last time I've apparently done this nearly exactly 1 year ago. That time flies by. Anyway, yeah, so that also worked. Here, change root in here, that works. That was the cat version, that one. The new one, I left the old one here because why not? You never know if the new one works. The new one is just from last night, so just 1 year later so far. So fast time travels. Welcome everyone in the audience, comments audience. What are the odds? Christian was tinkering with Retroflex, something which has the Pi0. Cool stuff. And again, this is of course, although it has here mini HDMI, and I even have USB serial dongle, but I think serial, maybe you need a need to solder there, and maybe it's only for 5 volt TTL. Anyway, as you see, how do we test this build? And by the way, fun fact, everything built, let's error list. So everything built except the Linux kernel, because I didn't had some board chosen. As I said earlier, this funny ARM stuff that it's not like one or universal build. And what is the other? I touched Perl. So right, maybe only Perl, the generically broken, you see each time we update Perl, the cross build stuff builds. So maybe I do this later tonight, as we want to get these images out. And this image I will publish, but I will even publish it without a kernel, because everyone has its own ARM board. And as you see, you can just extract the kernel from your official ARM board support kit there. And then we rsynced this here completely, which, by the way, fun fact, we could check the size. How long does it run? Oh, wait a second. I think I actually have proc and stuff mounted. Then probably DU does anyway. Let's just change root into here. So change root, of course, changing the root file system as visible to actually the namespace of this process. And here's freshly built. You see the Debian or whatever this was based on here, some older stuff, bash hello version 4412, and also GCC whatever. So 6.3 something, and change root here to our last night's build is 5.0.0. So I probably should check whether this has a new update. And GCC, of course, latest and greatest, 9.2. One thing, of course, the old GCC and stuff, not the worst thing, because it is slightly faster. And also the glibc is larger, right? So this is a stripped and size optimized build. Yet when you compare here, actually the Debian or whatever that is, the glibc is totally wherever. So you need to LLD here some binary to find the place, and this is also Zoomlink. So that was 1.2 megabyte, and the new one here is, or maybe from last year it is also not that version. So yeah, this is newer. So you see how much larger software becomes, although we probably did I size optimize. I thought I did. Let's double check that. Config arm config is size. Okay, sorry, I take this back. It's speed optimized so much to that. Anyway, either it is size versus speed optimization, or this stuff just becomes larger. The new one from last night, of course, is maybe even larger. 1.5, yeah, so the recurring theme here. So, but again, if you want all the latest and greatest features and security fixes, then there is no way around the latest and greatest software version anyway. One thing is curious, so I have here 2 logins, as you see, and so far everything works, including the quite hacked VI that we hacked together last night. Too long to get this autoconf stuff tweaked. But one thing that is really annoying, and I'm not actually, okay, this will not my Synapse service. One thing I find a little bit annoying is this interactive search. So I'm all used, like, you can type here something and search it. This new interactive search is a little bit, yeah, because somehow I always like these, and yeah, because then you can't navigate, and yeah, it's I'm not sure, not the super greatest fan of all the latest and greatest interactive features. That is why I was using NVI, but somehow, as seen, this is now become with BDB and whatnot, so database driven undo management, and also not the most amazing, apparently easier to cross compile the Vim than more feature rich Vim improved than bloody old NVI. But everything works, even the compiler. I compiled already a couple of stuff here. One thing is slightly curious, so not only is this of course super slow, right? I wanted to emerge Tmux just for the permanent console management stuff that you've seen the other day, and yeah, actually the default color is here green or so. This is why I switched this to blue. Actually, no, I remember a little bit neon. But this is also why I usually cross-compile as much as possible, right? Just emerging here the base installation with all the mostly important packages, var ADM packages. So that would be those, actually not too many. And maybe we even strip this down a little bit further. And just emerging Tmux and lib events that it needs takes 20 minutes on this Raspberry Pi Zero, and yeah, it's only 702 gigahertz CPU scaling stuff of, yeah, whatever. But this is also why I cross-compile as much as possible, not like other, like maybe Open Embedded or stuff, running stuff in QEMU or even on real hardware over Secure Shell and stuff. Not only is this setup much more complex and error prone, it's also super much slower. What else would we need? Yeah, so this also fun fact, this is also strange. We have seen this in T2. This is where all the work and time on details is going. So cross-compiled, everything works here. And you see, I even then went ahead and manually built here lib event and like cross-compiled, like target config arm job 1 lib event and Tmux, because so lib event built natively, and yeah, 2019 this stuff compiles more, cross-compiles natively. Somehow Tmux didn't build with some path mux not found. I'm actually not quite sure why. This should of course be in user include limits.h, but somehow it isn't, and maybe this is related. We had this issue bootstrapping other T2 builds, and this MC, whatever, MC or MB LAN that even some other people had like x86 images. So there is definitely a little bit tiny small glitch of kind of header support there of GCC or glibc. Actually, we can check here. So this is a Raspberry Pi, as you see from the host name there anyway. So that would be limits.h in var adm flist, all of those, and that is actually here in ARM. That is interesting. Maybe let's see where it is natively. Maybe that is here, this user lib something. It's also a little bit funny that in libr includes, so this is most likely not much that well, there's always a chance that we misconfigure something, but it's also most likely GCC just defaulting to this for some kind of reason and needs extra configuration guidance to do it more usable. So that is native here, grep config h or admf list. Let's see if that is in, not config h, what am I even, user include limits.h. Did I correctly check for limit? Yeah, so actually this is also in glibc, interesting. So do we have this in glibc, or actually there is a, okay, whatever. A little bit strange. I also wonder, this is the same compiler, so this is the same build, and cross-compiling it builds and natively, not some small glitches. But yeah, what I will actually do next is, this is basically mostly the overview. Of course, normally this board here is a little bit special with Wi-Fi. This is a little bit also exceptionally that we install and tinker on the board over Wi-Fi. Usually you would do this over serial, attach here also how tiny is this board here in contrast to my hands, right? But usually you would do this over serial, JTAG, flash or whatever, or on the, directly on the SD card. Of course, a little bit 2019, doing this over Wi-Fi. Yeah, welcome everyone, Danny Detard. I hope those people who are new to this learn here something. And anyway, mostly documenting also how much work this is. And next, so another day, we certainly have so much to do, which is also including keeping ourselves busy here, and why we need here this $3 YouTube AdSense plus Patreon. And by the way, thank you everyone for all the new people on Patreon, much appreciated. Because next, so you see, we have here still some initRD stuff to do. Cross-compile Perl, Mason and Ninja, which remind me, does the cross-compiled Python even work? Okay, it does something, although it's missing the Python link, which might be because although I fixed this already, I thought at least it works a little bit because Mason and Ninja do not yet build, need some, so probably in T2, there you see also the many languages, right? All the languages used, each and every one needs some special attention and configuration guidance and persuasion with some good old code, some slash hammer of code around it. And so all this stuff, most likely this initRD stuff of our just last night changed mbutils and didelibc removal, of having more streamlined, simple, how we like it, T2 generic images without extraordinary stuff on it. And next, I also need to check here cross build limits.h, and somehow also this MB or what was it, MB, this was multi or VC MB length or whatever that was, need to check. But the good news is, as soon as first of all, this works certainly as always, unless it's in a regression. But this kind of small things always, often happens. That you build everything worked, and then you have these small glitches which keep us busy. What I will do next, and I already prepared this benchmark that we have run here, CPU test irsync is also over already, and I wanted to run this here now and see, although again it's not a totally fair comparison, because we compare a little bit apples and oranges, because I recently made changes. This test suite was using system binaries for compressed data sources, although I actually rsynced this. Actually, so this will be comparable to the x86 builds because I rsynced it completely with the dataset. But we will soon, like next year, when we redo this, I will make sure that these results are entirely identically comparable for the future. But there you also see already, I'm actually curious, is this maximum 1 gigahertz, I think, Raspberry Pi faster than an SGI Octane? Maybe it actually is. 21 seconds. And there you see, when you wonder why I'm not running something like Phoronix test base and this homemade, although most likely I have made this before the Phoronix test suite, because I've actually created this in 2005 for Linux Magazine articles, this OpenBench, which was the whole time open source. And I modeled it a little bit to what I've never seen, this spec suite, which is often used for commercial, professional benchmarking. I've never seen the source, so I modeled it a little bit like running individual packages like even libmet and lame and gzip, and maybe we expand this even. The reason is, although it's super fast on something like Ryzen, where I think on the Ryzen this probably built in fractions of a second, this old-fashioned bzip2, but you see on this Raspberry Pi it needs a whopping 21 seconds. Also slightly wonder why the second build is slower. Usually the second build is more cached. But I will run this benchmark, and as soon as it is done, I will publish the results. Really curious where it sorts in there, although again slightly unfair, at least well, partially unfair, because we have a build time, and the build time vastly varies with compiler version, as we have seen, C-Lang, GCC, and all the versions. But runtime a little bit comparable. Certainly really curious where it sorts in there. And yes, it is not the most high performance Raspberry Pi, but maybe we get this soon also just for the testing and fun of it. But this certainly for automation and other fun stuff. And yeah, certainly, again, this explains why we cross-compile. Welcome everyone there, by the way, in the audience. Again, just a reminder why we are cross-compiling and why you should probably do, because if we would offload even this, if we attach this to the Ryzen and offload some compilation, it doesn't really help much. It's much better we fix as much as possible, and maybe another fun stream, leave me in the comments below if we should do that. So many stuff we can do here together on YouTube is, well, together you watch, I do, but we can already cross-compile half of the packages, I think, approximately. We can actually check that. Can we maybe cross in package arm packages that might have all, wait, hello, not packages, oops, config arm packages. So let's word count this. Is it, yeah, actually one, yeah, whopping maybe plus minus once. This is also what I had in memory. I had 1500 in memory, because I think a couple of years ago we could cross-compile 1500 packages, which are certainly, you see how many this are, how many packages this are, and let's get this. This might not be all packages. Wait a second, these are all, these are only, okay. What the heck was this? Anyway, we have some, this probably maybe only now cross-compile packages or something, because it's a configured cross-build. Let's just ls all desk files. These are all packages, and yes, 3700. No Lua there. Okay. Scale equals 4, and then 1600. Yeah, it's not really 50% anymore. I think some couple of years ago we could cross-compile 50%. When I did some, it's only down to 43% because we added so many packages. But we certainly could do another live stream trying to cross-compile even more packages. Actually, a decade ago, fun fact, how did I do this? A decade ago, I simply marked all packages cross-compile, and then I was, of course, they were all failing because they couldn't yet cross-compile. And then I was sitting there a whole week or so and fixing one after another, like workarounding, improving our T2 build infrastructure, the build scripts here. And yeah, so this works. I also have the Origin 200 and Hewlett Packard PA-RISC here next to me. For when I said 4 weeks T2 release season, I really meant it. And yeah, we're getting there. And it's always good to test this, that these binaries really work, because you can imagine it can easily be you cross-compiled and it doesn't even work. I had this actually in the past. The customer asked there in Florida, for example, for some security stuff, they wanted ARM, I think, big Endian ARM. And fun fact, I still have this embedded product, probably can take it out of the storage. Because normally ARM is little endian, but there is also big endian variants as well as MIPS was historically big endian like on SG Octane, but they're also little endian, or maybe nowadays most of the embedded stuff is little endian. And yeah, it can often happen you cross-compile something, and because there is something with the configuration or regression, nobody tested this, or the configuration is a little bit off, and then it cross-compiles but only segmentation faults. This of course you see stable enough. Not only did we log in and compiled lib event or mostly Tmux, nothing crashed, downloads worked, even everything is all those bash scripts and Lua acceleration, so all the fancy stuff in T2 works. And here the benchmark even runs, so compiler is compiling and producing some working binaries. And yeah, this test is still running, so much to recompressing this 100 megabyte of BSIP2 stuff takes forever. And yeah, just again, when you wondered why are these benchmarks so quick here, it's not as quick on embedded hardware. That's it for this live stream. I have a conference call. Hope you enjoyed this. This can run there in the background for a couple of hours. Certainly. Hope you learned something. As always, leave me in the comments. What do you find most helpful? What do you want to see? More embedded stuff. Certainly, by the way, fun fact, it sounds like some FPGA board might be soon on the way to me, as well as a mechanical DIY keyboard kit. So plenty of stuff to come that you probably want to share, like, and subscribe for. And one last tip, what is really for me always the first thing, so this is Debian. Fun tip, my most missed alias is ... command not found. That is a default alias in T2 to change the directory, and the three dots for user source T2 to go 2 down. This is actually each time I log into some other distribution. Yes, it's only one alias away, but this is of course a little bit nice. Also, yeah, Debian doesn't have, or whatever that is, doesn't have L, and also not LL. I think Fedora might have LL, but T2 has historically, with Rock Linux default, the most used commands L for list with for ls -l, list as list, and yeah, L and ... just as a tiny productivity shell tip here. And I hope to see you soon for all the next fun stuff to come.